Hello students, today we are going to discuss refraction through glass prism, triangular glass prism ABC, and finally we will reach to the expression for the refractive index of the glass prism. Suppose this monochromatic light is incident on face AB and this is normal at the point of incidence. We know that the angle between normal and incident light ray is known as angle of incidence. This is angle of incidence I, and the angle of refraction is R1. The light ray bends towards the normal when it goes from rarer medium to denser medium. As we are observing, light ray goes to this path. And finally, after traveling through the glass prism, it reaches to the point R. And this is normal at point R. And now, the condition is reversed. The light ray goes from denser medium to rarer medium, so it bends away from normal. This way, है ना? So, this angle is known as angle of emergence. What is the direction of incident light ray? The direction of incident light ray was this. And what is the emergent light ray? Emergent light ray is this. If we extend it to the back side, then we found that these two light rays intersect at point S. Uh, at this point, we can conclude that the light ray, after passing through the prism, is bent by the angle delta. This angle is known as angle of deviation, and it gives us the measurement of bending of light ray when it passes through a glass prism. So it is the angle between incident light ray and emergent light ray. We will derive the expression for delta also. We will derive the expression for R1, R2 and A. Suppose we are considering to the quadrilateral APQR. We know sum of all four angles in quadrilateral is 360 degree. Angle A, it is also known as the angle of prism. Angle P, it is 90 degree because it is normal. Now this is angle 90 degree, and this is angle Q. This is angle 90 degree at R. 90 degree is equal to 360 degree. So we can come to this equation A plus Q equal to 180 degree. And triangle A, in triangle PQR, this is a small triangle, lower triangle. We also know the property of triangle. Sum of all angles is equal to 180 degree in any triangle. So we can write R1 plus R2 plus angle Q is equal to 180 degree. From equation 1, we can see that Q becomes equal to 180 degree minus A. It can be put in this equation 180 degree minus A equal to 180 degree. So R1 plus R2, 180 degree is cancelled by 180 degree on right side. So R1 plus R2 becomes equal to A. It is equation 2. It is very well known equation and generally asked in CBSE examinations. And generally it is asked in this way that drive the expression for angle of prism, or drive the expression which gives the relation between angle of prism and angle of refractions at both faces. Now we can calculate the angle of deviation delta in this upper triangle. In this triangle, in this diagram we are seeing that these two lines are intersecting each other. So if this angle is I, then this complete angle is also I. If this angle is R1, then the remaining angle is I minus R1, and similarly this upper angle is also E minus R2. So in any triangle, the exterior angle is equal to the sum of opposite two interior angles. So delta is equal to I minus R1 plus E minus R2. I have written here delta is equal to I minus R1 plus E minus R2. We can simplify it as delta equal to I plus E minus R1 plus R2 using equation number 2. R1 plus R2 equal to A. We can write delta equal to I plus E minus A. This equation is very useful equation. It gives us the nature of the light ray. If we interchange I and E, then this equation says that delta remains same. And we also know the reversibility of the light ray. So by this we can come to know what will be the shape of the graph of delta and I. Come to the diagram. Suppose any time the angle of incidence is 40 degree and angle of emergence is 30 degree. Suppose these two values for a particular case. If I just reverse the direction of the incident light ray, if incident it from this side, then due to reversibility it retraces to this. And if at this time the angle of incident at this phase is 40 degree, then angle of emergence becomes 30 degree. Means one time if I am taking this 40 degree, it is 30 degree. If I make this angle 30 degree, then this angle becomes 40 degree. means delta is same for two values of angle of incidence, 30 degree and 40 degree. So what type of the shape of the graph should be, which gives the relation between delta and I? It should be of this shape. We can take the idea of the graph. So in this equation, in this graph, we can see delta is, this graph is giving two values for a single delta. For this value, I am seeing that some values here and some values here. If I am decreasing this value, I am taking this, then I and E, they comes closer. At the minimum angle of deviation, delta equal to dm, I am taking this symbol for minimum deviation. The I and E merge to each other. I become equal to E. At minimum deviation, that is delta equal to dm, we can see that I become equal to E. R1 becomes equal to R2. How? In this diagram, we can see if this angle and this angle are same, means angle of incidence on both faces is same, due to uniform refractive index of the triangle, we can say that the bending of the light ray should also be same at both points. That's why this angle and this angle both become same. And if these two angles become same, and this is a triangle with these two sides same, then this side becomes parallel to BC. I have written here PR parallel to BC. Let R1 equal to R2, and I'm choosing a collective symbol for them, R. Say, from equation 2, we can write R1 plus R2 equal to A, R1 plus R2 equal to A. So it becomes R plus R equal to A, R equal to A by 2. Now let I equal to E equal to I. I am choosing a collective symbol for it using equation number 3. Equation number 3, delta equal to I plus E minus A. So dm, at place of delta, we are considering at the minimum deviation, so delta should be written as dm. So dm equal to I plus I minus A. So I should be equal to A plus dm by 2. Now we are in the position to apply Snell's law for refractive index. Snell's law, we can write refractive index n is equal to sine I. I means A plus dm by 2 upon sine R. R means A by 2. Sin I upon sin R equal to n. So n equal to sin A plus dm by 2 upon sin A by 2. This is the final expression for the refractive index.